Welcome to this video in which I desire analyze the condition for whom a Goldbach conjecture is satisfied. Maybe you know what Goldbach conjecture says. In other words, Goldbach conjecture says that every even number greater than 2 splits in the sum of 2 odd prime numbers, or 1 and an odd prime number. So that to analyze the condition for whom Goldbach conjecture is satisfied, we can fix a positive integer n. For example, n equal to 24. So that 2 for n is equal to 48, and is immediately checkable that the unique prime numbers that coprime with 48 are 2 and 3. So that our first task is to calculate the number between 1 and 48 coprime with 48. And this number is given by Euler-Tolkien function phi. In fact, phi of 48 is equal to 48 for the product over pi number that divide 48 pi of 1 minus 1 over pi, that give 16. So that we know that between 1 and 48 there are 16 positive integers, such that positive integer m, such that m is coprime with 48. Observe that for n greater than 2, phi gives always gives an even number. So that now our second task is to list these 16 numbers: 1, 47, 5, 48, 3, 7, 41, 11, 37, 13, 35, 16, 31, 19, 29, 23, and 25. There are between 1 and 48, coprime with 48. Now, observe that we can build we can build 1/2 for 16 boxes, such that every box contains two numbers. And such that these two numbers sums to 48. Since if K is coprime with 2n, or with n minus K is also coprime with n. So that in these boxes we can put the elements of the pairs of positive of coprime with 48 numbers that sums to 48, 1, 47, 5, 43, and so on. I written in red the number belonging to the set of prime number to which I've adjoined 1. And in black ink, the composite coprime to 48 between 24 and 48. That is 35 and 25. Now we have again to observe that if K plus the pair KH such that K plus H equal to 5. And K is between 1 and n set of pairs of positive integer if k is coprime to 2 for n, also h is coprime to 2 for n. And if k is not coprime to 2 for n, also h is not coprime to 2 for n. So that the elements of this pair are both coprime with 2n or both not coprime with 2 for 2n. So that the element k in this pair mutually cancel out with the element h in this pair. K, if k and h are not coprime with 2n, the number of k mutually cancel out with the number of h. In other words, there is a bijective function that sends a bijective function f that sends f that sends k in h is 1 to 1 and on 2. So that we can omit in our next calculation, we can omit to take in consideration k h not coprime with 2n because mutually cancel out. Now we are free to draw some conclusion, to complete our analysis of the condition because Goldbach conjecture is satisfied for 48. Observe that we have 1, 2, 3, 4, 5, 6, 7, 8 numbers that are 1 or a non-prime number between 1 and 24 composite coprime with 48 between 25 and 48, so that the number of red numbers is greater than the numbers of black numbers. We can state that prime numbers, pi between 1 and n and coprime with n, are greater, strictly greater, than the number of the set of composite m between n and 2n and m coprime with n. And this is enough to state that there are the conditions for whom Goldbach conjecture is satisfied. The fact that the prime numbers between 1 and 24 is greater than the set of composite coprime with 48 between 25 and 48 is enough to state that for 48 Goldbach conjecture is observed. So that we can summarize with this formula. If the prime numbers between 1 and n and coprime with n is greater than the number of composite m between n and 2n and m and n coprime. These allows us to state that we have a strategy to prove Goldbach conjecture.